Yeah, yeah. Thank you. Thank you for coming. And yeah, this is Philip Hyunsu Cho, and I'm today. I'd like to give you a talk on State of XGBoost, a brief history and major milestones you should be watch out for. And about me, I'm the lead maintainer of XGBoost since November 2017, and a disclaimer, I do not represent my employee here. I'm giving a talk as the lead maintainer of the open source XGBoost project. Brief history on here. The first XGBoost was first created by Tenchu Chen from University of Washington. He he created the project as his master's thesis. He felt that he did he didn't find existing packages for gradient boosting adequate for his needs, so he created XGBoost. And and then so I actually had a chance of knowing him personally because we actually went to same school. We had the same PhD advisor, so that's how I got to know him. In September 2014, the we submitted our package to CRAN, the R package index. So the funny story is that our package actually came before the Python package. And then in May 2015, XGBoost integrated itself with scikit-learn. This is a really common pattern. Whenever XGBoost project has integrated with key packages such as scikit-learn, our value increase exponentially. A lot of people find it more useful because it can work with other packages. So yeah, scikit-learn is, you can think of scikit-learn as the gold standard for machine learning in Python. So people use it as a reference implementation. So yeah, having an API that looks like and feels like scikit-learn is crucial for our success. In August 2015, we made first submission to Python package index. So now, since then, you are now able to install XGBoost with just running pip install, which is very convenient. And in July 2016, was when XGBoost first started supporting Spark. And then in August that year, XGBoost was published in ACM KDD conference. So knowledge for data and discovery. I think that's what it stands for. I need to look it up. And so much after that, there was not much activity later until around 2017 December. That's when XGBoost had another major round of improvement. XGBoost gained an experimental support for NVIDIA GPUs. That's when Laurie Mitchell from, well, currently for NVIDIA, he actually joined the project and then started really pushing the project forward. And then also, I made my first contribution around the same time, where I actually added a faster tree construction algorithm called HIST, where instead of having to enumerate all the possible feature values, we can reduce amount of computation you have by only considering the approximate quantiles. So instead of having to say enumerate thousands of feature values, you just list 200 quantiles, let's say. So that reduces the number of possible thresholds you would have to consider when splitting on continuous variables and speed up computation a lot. So we were actually inspired by LightGBM, who also adopted this approach. And around the same time, Scott Lomberberg, also a colleague from University of Washington, he contributed SHAP, which is a very nice way of quantifying how much each feature contributes to a given prediction. Yeah, for example, in this visualization, you can see that there are two features that positively contribute to the particular prediction, and then there are other features that negatively contribute to the particular prediction. So given a particular prediction, given a particular input, you can say that which feature have positive or negative impact. So in other words, you can actually explain why your XGBoost model makes a particular prediction. It's very useful. And in 2018 of 18 June, that's when the support for NVIDIA GPU was no longer considered experimental, and then there's now first class support since then. What that means is that, well, there's a lot of testing infrastructure that to support NVIDIA GPUs, and then there's a lot of demos and then blog posts and so forth. And then August 2018, Spark API was actually significantly revised because the previous style did not really fit with how MLlib was working. So MLlib, well, may not be the fastest, but it's also a quite nice API with idiomatic uses of Spark pipeline. So we decided to also work with convention rather than just be unique. And in January 2019, we won the InfoWars Technology of the Year award. And February 2020, that's when we finally released 1.0. And then we signify that the XGBoost is no longer experimental, it's actually quite mature software. And we also added support for Dask. We are going to actually talk about it in a bit. And so XGBoost has gotten popular over time. So a little bit before 2016 was when it first exceeded 100 stars, but then since then it has grown to receive more than 20 stars now. And XGBoost also has more than 10,000 lines of code at this point in time. So it's a quite massive project. And now I'm going to quickly go over some recent developments that you should be excited about. Well, first of all, is faster performance on multi-core CPUs. It used to be quite bad. So in the previous talk, in the previous talks, we actually have given a detailed benchmark results for XGBoost, so I'm not going to cover it again. But it used to be really bad. This is a really worst case scenario where having 36 CPU cores actually led to 5x slowdown. That was really bad. However, folks from Intel have contributed to our project so that it would become faster now. It was actually quite long work from December 2018 all the way to February 2020. And yeah, so as a result, we actually now have a quite good scaling as well as acceptable performance even on a machine with multiple sockets. Yeah, and also very briefly, XGBoost also has a new format of specifying models. Well, why was it needed? The old format was binary, so you could not actually inspect it manually. So people had harder time writing tools that would visualize or parse XGBoost models in some way. Also, I've talked to a lot of users, and then one of the most major concern was that what if I have this super valuable model. This has lots of business insight, and I do not want to lose access to it. Now, if you use actually new JSON format, you do not have that fear anymore because JSON is human readable format. And in the worst case scenario, at least you can inspect it. You know what's going on. There's no dark magic going on anymore. Of course, we still really try hard to not break backward compatibility. We really try hard to ensure that you can read your model on newer versions, but nice JSON format will also give you just a little bit more assurance. Also, you can write a bunch of new tools that can read from the XGBoost models, such as visualization. And let me talk about Dask, the distributed training framework. It's quite lightweight and easy to set up. You can just use pip or conda. Personally, I quite prefer it to Spark, again, due to how lightweight it is. And also it plays well with common data types that we know and love, such as NumPy array or pandas data frame. And it's very easy to set it up and use. Like for example, you can actually declare a cluster consisting of 4 processes with using a context manager with local cluster and workers equals 4 as cluster, and then you define that client, and then you pass the client to XGBoost.dask interface. It's a little bit more involved if you actually have multiple nodes. So but this example only shows you 4 processes running in the same machine. Now it's actually very easy to use multiple NVIDIA GPUs. Like if you have 4 GPUs, for example, you just specify n workers equals 4 to local CUDA cluster, which is going to launch 4 processes, and each process will manage its own GPU. So it turns out that because we rely on Dask on multi GPU training, our code has simplified a lot. Trying to manage multiple GPUs on a single process was very complex, so we quickly abandoned it. Now our rate of progress is much faster because we delegate all the difficult part to Dask. Well, I guess, why would ever anyone use multiple GPUs? Well, first of all, like GPU memory is tend to be more limited. That's one reason why. And another reason might be that like I'm going to talk about this in a bit, but you can actually accelerate every part of your data pipeline on GPU rather than just the training part. So I'm going to return to that in a bit later. And major improvement is the zero copy data ingestion. XGBoost was a lot of people have complained how memory hungry it is, and we really try to dive in and then make some solution for that. So the reason is really that in Python, you can think of it as having 3 copies of training data simultaneously registered in memory, and that's going. So yeah, that's really bad. So what we really wanted is to let XGBoost consume data without making extra copies around. So now we have implemented a mechanism called device quantity matrix, where you which GPU algorithm can consume training data without making extra copies. It's going to be faster to show this as in a figure. So, for example, this is how much memory reduction you can actually achieve using zero copy the matrix. It used to, let's say, a data set that used to consume over 3 gig now consumes under 1 gig. This is what happens when you eliminate extra data copies. Also, on top of that, for prediction, we also support in-place prediction. So in other words, if you're only predicting a single row, you do not need to rebuild. You actually do not need to build the matrix. Actually, you can also do this with multiple rows. So yeah, but the benefits are much greater if you only have single row to predict. The report, it has been reported that the overhead of creating the matrix is up anywhere from 50% to 90% if you're just trying to predict a single row. So ability to pass in a NumPy array or CuPy array is really nice. And there's also end-to-end data pipeline with GPU on Rapids package collection. So Rapids is a collection of packages that let you do every step of the data science on NVIDIA GPU. So it lets you accelerate every part of the data processing pipeline. So including pre-processing, feature engineering, and then the actual model training. So what's surprising, I was quite surprised to learn this the first time, NVIDIA GPUs can now even parse CSV files. So it just parses the string and then be able to construct a matrix in GPU memory. So why is it important? It lets you iterate faster. And if you have access to NVIDIA GPU, you can iterate much faster. You can also try lots of hyperparameters. That comes in very handy in data science competition. Like for example, a KG Mon team from NVIDIA have won the first place in Twitter's Rexis Challenge, the recommender system competition. And what they say that overall, using Rapids, they have achieved 25x speed up over optimized CPU implementation. And they were able to run entire pipeline from pre-processing, engineering, and training in 2 minutes and 18 seconds. So as a result, they were able to make lots of fine adjustment and then tune the hyperparameters in a reasonable amount of time. You can actually try it today with app.blazing@sql.com. And this is a partner who graciously offers a free notebook server that lets you try out Rapids today. And the shop is really important feature. A lot of companies, like including finance companies, they really love this feature. But it was all quite slow, especially if you have to have pairwise feature interaction. If you have M feature, you would actually have to compute M squared times, and it was proving to be very slow. So what we wanted to do is to use NVIDIA GPUs to accelerate SHAP, and it's also going to be available in release 1.3.0. The results are still pending, but I can for now quickly say that it's also going to give you at least one order of magnitude faster using GPUs to compute SHA. And also, finally, improved testing. This is something that I, as a developer, strongly feel about. We now have more tests to cover the C++ code base. There's a lot. The XGBoost is a quite complex piece of code, and then there are a lot of things that can go wrong. Having a set of automated tests give us a peace of mind. Why is that important? Because this is an open source, so we accept pull requests from anybody. So automated testing farm actually ensures that every pull request is up to the quality bar. It also reduces work for me, the maintainer. As a result, we can make changes faster with confidence that we're not going to break anything. We can make releases with higher degree of confidence as well. And as a future roadmap, we are working on categorical data support. Well, you can use the categorical data today, but what you have to do today is that you have to first convert your categorical variable into a collection of binary dummy variables, which is okay-ish, but the problem, this actually does not work for everyone. Like dummy variables tend to increase memory consumption in XGBoost because XGBoost consumes as much memory as there are a number of features. Also, the problem is that now you end up having to feed a tree that's really deep because otherwise you may just not be able to capture all the extra dummy variables. So having a direct way to split on categorical feature is really nice. So a typical split would be asking a tree node asking whether a car manufacturer is Honda or something else. If Honda, go to left. If otherwise, go to right. So that's what we mean by categorical data support, and we are working hard on it. And also, we want to let XGBoost share memory pool with other packages. It turns out that memory allocation is quite expensive operation, and it's expensive on CPU side. It's more expensive on GPU side. So CUDA malloc would sometimes have a peak latency of 100 millisecond or even more. So what we what people have come up with here is to have allocate a gigantic memory pool, pre-allocated memory pool, and just to subdivide subsequent memory allocation from the pre-allocated memory pool. It actually speeds up performance quite a bit. So the problem with this approach is that if you have XGBoost and some other package that also use GPU memory, you're gonna have contention. So the solution to that is to have a common standard that lets XGBoost share a common memory pool with other packages, such as CuPy, cuDF, or even PyTorch. Um, Lastly, we want to really get our acts together and clean up C++ code base. There's a lot of duplicated code around, and you may notice that some features are available on GPU and not on CPU or other way around, because CPU implementation is quite separate from GPU implementation. It adds a lot of maintenance burden for us, so, and also deters future contributors, so we do not want that. We want to really clean up. So that's end of my talk. You can reach me at chohyu01 at cs.washington.edu. And you can also reach me at Twitter or GitHub. This is also my GitHub account. You will see me very often if you go to XGBoost project repository. And also, I would like to make a super quick call for additional contributors. Why? Because there are parts of XGBoost that need more care. For example, our package hasn't had much maintenance lately, and I really feel bad about that. But I mean, there are only 3 of us in the entire world that maintain XGBoost more or less full time, and that means we can do only so much. So if you really strongly feel about having a new feature or improve maintenance on XGBoost, feel free to reach out to me. We can try to work something out together. Also, try considering making donation to our testing infrastructure. We have a sponsor button on GitHub. Yeah, thanks everyone. I would like to open up for question. Thanks.
All right, thank you, Philip. Great talk. So there are a couple of questions. Here's the first one. How much of the CPU scaling improvements can be attributed to x86 specific optimizations?
I would, comparatively little is my answer. I have actually we've had a chance to review Intel's contribution. And well, one thing they did do is they actually used prefetch intrinsic, prefetch intrinsic, which is only available on some CPU but not others. But I mean, that's okay because I think we can, like, when we build actually from source, we actually do something called a feature testing to ensure that you can actually build XGBoost on other architectures that do not have prefetch intrinsic. So other than prefetch, most of the thing is not really specific to x86, but more toward have a better utilization of multi-core CPUs in general. It really helped to have like a lot of times before, what used to happen is that some threads would run out of work before other threads, and then so what we ended up doing is we have some kind of a way to fairly allocate work so that threads can be fully utilized. That would be my answer to your question.
All right. Next one. Do you know if splitting on categorical variable is fundamentally better than splitting on the one-hot encoded variable? There are blogs claiming this.
I think some people do claim that. Well, again, the question I would ask back to better in what sense? So I did mention that it would be definitely better from performance perspective. like it has potential of consuming less memory. It will also, not means that do not actually have to do one hot encoding, which also takes time. However, from data science perspective, I'm not an expert on that, so it's hard to say. People do have alternative means of handling categorical data, such as target encoding, but it also has some disadvantages. At least that's what I hear. So it depends, is my answer.
Okay, great. I never asked the which model is better question because I can just run them and compare their scores. But when I do see that XGBoost is superior or inferior on a given data set, how can I explain the reason behind? Is it some feature types, distributions, relationships? Is better, worse modeling? Is it a hyperparameter I'm supposed to be tuning more?
Well, first of all, data categorical data support is something that we would try to improve on. We would also need to improve testing. I would say that cat boost. Well, by the name actually implies categorical boosting. They actually have designed cat boost with categorical data in mind. So that part, we can maybe say that cat boost is superior in that sense. Other than that, uh, in terms of accuracy or performance, it's quite hard to say. I mean, the now like GBM and XGBoost have more or less similar algorithm-wise. When you like the hist tree method in XGBoost is quite equivalent to what like GBM does. So it's a matter of implementation detail, and it's really hard to say. I believe that Light GBM has some more optimization that makes it potentially faster and scale better for some data sets, but I have not had a chance to look at that yet.
All right. I also have, it's more like a comment. So I just find out from your talk that I didn't know that you were the one implemented HIST, and HIST
Yeah.
is obviously it's great when, unlike larger data sets, when you compare it to the exact method, you get like, I don't know, 10x speed at least. So really great. All right, next question. When doing tree building, does XGBoost use a breadth first search approach or a depth first search approach?
What for prediction or for training?
They say, yeah, training.
Okay. You can, so if for hist method, for hist and GPU hist, you can actually choose. You can set grow policy hyperparameter. Usually the default is depth-wise, is which just grows tree in depth first. Depth-wise, well, it actually means one level at a time. So first level, you would actually fill the second level before the third level, and then before the fourth level, and so forth. The growth loss guide, on the other hand, is going to not try to have a balanced tree at all, but just going to always expand the node that's going to result in the highest loss reduction. So it might actually, loss guide actually will potentially give you a highly unbalanced tree. So you can actually choose between the two methods.
All right. Any more questions? Are there any gradient boosting techniques that are appropriate to time-dependent data, like multiple customer transactions over time?
Oh, that's really hard to say. Time series is something that I would like to get into at some point, but right now, at least the XGBoost, the formulation of XGBoost assume the IID data, so which I'm not sure how we can deal with time dependency. Um, so yeah,
Yeah, what I other people doing is that try to do that with feature engineering in kind of transforming your problem into some other problem. where you have like, let's say, lags and this kind of things, and then you create new variables, and those variables will be more of like the traditional independent kind of like, so that you can just use XGBoost on that. That makes
I see. That's interesting. I guess another option that I can think of is that you can use neural networks to explicitly model sequences. That's another option I can think of.
Okay. New question. Are there plans to add support to XGBoost for modeling export sharing formats like PMML or ONNX?
Well, we do not have a concrete plan yet. I know that there is a feature request open for Onyx Exporter. We have not got around doing that yet. Only thing that's available is you can now save your model as JSON format, but that still means that you're gonna have to manually convert. So that's still not ideal. We really want to have a native Onyx export. There is actually a third-party package that converts XGBoost into Onyx, but it would be better if we had a first-class support for it so that we can test it better.
Okay. Has in your experience XGBoost been fragile to mislabeled observations in the training set due to increase in residuals weight? If so, is there any feature in the roadmap to mitigate that?
A mislabeled label?
Yeah, so he's asking about fragility or sensitivity to mislabeled observations. So I guess a number of, like, let's say a given proportion of labels flipped randomly or something like that.
We do not have a concrete plan for it either. I have not seen a feature request for that effect. So if you actually think it would be very useful, please feel free to file a feature request. We will try to consider it. So yeah, it might not be related, but we actually did add support for pseudo Huber loss, which is supposed to be more loss for outliers. But I think it refers to outlier in the training data rather than the label,
Yeah.
so it might not help.
Yeah. All right. Any more questions? All right, I guess that's it. So thank you, Philip, again for this great talk. And thank you, all of you who attended this meeting. And thank you for your patience until we managed to sort out this Zoom link.